Hey everyone.
Hey,
So
hello.
I see people joining in. Yes, people have tuned in. So for folks who've just joined in, we'll wait for a minute and let other people's roll in as well. I'm Harshit Paul. I'm joining in from India, and we have Philip with us, who's in from Slovakia. Let us know where you're all tuning in from. We'd love to know. Hey Paul, good
Hey.
afternoon. So that's good afternoon for him. It's good night for me over here in India at this time, and it's going to be midnight where Philip is tuning in from as well. So
Yeah,
Russ
it's a
is
late
tuning in
night
from
show for
Mars.
me.
So that's interesting. Jumped in out of
Oh,
my
nice.
question.
We got some
St.
Martians
Louis.
here.
Yeah, we got some Martians. St. Louis in the US, Terry, Katrine from Germany. Nice. We have somebody from Nashville, Lisa. Hey, Lisa. Perfect. We have folks from Czech Republic. So pretty much
Oh,
all around the globe,
hey, Katka.
folks have joined in. And having said that, it's about time we kick in. So, good morning, good afternoon, and good evening, everyone, and welcome to another session of TestMu 2024. I'm Harshit Paul, Director of Product Marketing at Lambda Test, and I'm thrilled to be your host for this session where we are going to talk about how to start unflaking your tests. Yes, you heard that right. Today, we are diving into a topic that's crucial for anyone involved in the software testing and quality assurance process, and especially concerned about improving the effectiveness and efficiency of the overall test process. But instead of just scratching the surface, we're going to address the real issues head on and explore actionable strategies which can truly transform your overall testing lifecycle. But before we get started, a few housekeeping items. This webinar is going to be 45 minutes long and is going to be fully recorded. So, in case you need to drop off midway, you can find the full recording of this session over our YouTube channel at Lambda Test. You can also find the full recording over the TestMu platform where you're watching us right now. And you will also get the full recording over to your registered email address. And having said that, while we are presenting anything, and if you have any questions popping up, feel free to address them in the Q&A box so we can take them towards the end of the session. And now I would like to introduce Philip once again, Filip Hric, who is at DevRel at replay.io, where he bridges the gap between testers and developers. He's also a Cypress.io ambassador with an extensive experience and expertise in test automation. Philip has taught hundreds of testers and developers through his workshops, and he has his own blog as well, which contributes to it, philiphric.com, where he shares valuable insights, tips, and disclose actionable strategies which can help you work your way through Cypress.io. Thank you so much for joining us, Philip. The stage is yours.
Thank you. Thank you very much for having me. I would give one small life update in terms of my introduction. I was introduced as a DevRel for Replay.io. Unfortunately, last month there has been a layoff at Replay.io, and it has affected me and a bunch of my colleagues. So if you're looking for great engineers, I can give you some great names of colleagues that I have been working with. I have been also affected, but that means that I have now more time to do more teaching and more consulting and stuff like that. So I'm back to having some more fun with Cypress and the conferences and stuff like that. So that's fine. Um, Also, yeah, thank you, Harshit, for giving me a nice introduction. Thank you for reading the title correctly, because the title of the presentation is how to start unflaking your tests, right? So the flake is the real dirty word here. And this presentation is all about how to get rid of the flake, how to get rid of it, because it makes testing more painful and less enjoyable. You might remember that feeling you had when you first started writing your UI tests, which opened the page and clicked through until it turned all green and you had a successful test, right? The thing you had to do manually is now automated, and that's awesome. Um, and I remember a time when I was just starting the test automation, and what I would do is I would raise my colleague to see, like, if she can go through the critical scenarios manually or whether the test automation wins. And over time, we have built up a confidence in test automation so that we no longer needed manual checks. And as we added more and more tests, we were really happy. But then something started brewing in the background, something that started to break our confidence and slowly build up an anxiety about our test automation. And we would start trusting our tests less and less and started relying on manual checks again. Um, it almost felt like checking stuff manually was, in a way, faster. So that's weird, right? And it was all caused by a single problem, and that's test flakiness. So, what is test flakiness? Simply put, test flakes happens when a test gives you inconsistent results. So, for example, if you run a test 100 times, it should give you the same result 100 times. And if it doesn't, and there is no known reason for a different result, like a change in test or change in the application, then it is considered flaky. So, why does flakiness happen? Well, the short answer is because things are complicated, right? Essentially, when you're writing end to end tests, we attempt to write a program that automates another program, right? And you can imagine it as integrating two systems. One system being the app and the other system being your test. So a good test fits the app like two cogwheels fit together. And when things start to grind, that's where flakiness happens. And this is why we need to think about flakiness. It's not only about the fact that we need to fix some code. Obviously, we need to do that, but there's it has a ripple effect on the whole organization. It might result in loss of confidence in test automation. It might result in doing manual work. You need to check your flows manually now that your tests are flaky. The delivery may slow down. You need to rerun a pipeline. Developers are waiting, right? Loss of test coverage. Maybe you choose to ignore or quarantine a test or two now. Execution slowdown, right? If your test need to retry to avoid the failure because of the flaky test, then that's going to slow you down. Added debugging time, right? When you have CI related issues, but then you like don't really have an option to replicate them locally. That's troublesome. Uh, and but most importantly, I think, is the loss of trust in QA process. That's the kind of impact that flaky tests have. And I think that's something testers might fear right now because with the rise of AI and ever-present demand on cost cutting, it's higher than ever. So flakiness is a huge problem. Um, yeah. So I have consulted and collaborated with many companies, varying from like e-commerce through fintech through SaaS services, and I have seen these so-called strategies helping us live with the fact that our tests are flaky. And examples of those are like muting a test, quarantining a test, retrying a test, adding a longer timeout, reproducing a test locally, deleting a test, or as I like to call them, shock, denial, anger, bargaining, depression, acceptance. So that's a little joke from there. If you got it, kudos to you. Uh, but also, there is one strategy of fixing your test that actually works, and that's, well, fix the damn problem, right? Or don't create it in the first place. But of course, this is easier said than done. And as the test automation grows, the problems with flaky tests grow as well. So the question is, how do you fix it? Generally, as a project scales, there are three axes on which the project grows. So the first axis is test coverage, basically the number of tests, right? You have more tests, there's higher chance of your test getting flaky. Uh, then we have test execution, right? So this is connected to the way how you execute your tests. So usually that means like dealing with stuff such as parallelism and pipelines and figuring out which tests to run, etc. So that's the test execution part, and this is where things can get flaky. The other area is test performance, sort of a z-axis, right? And this pretty much means the speed of how individual tests execute. And flakiness can occur on any one of these axes. So today I'd like to talk about some of the areas, right? So on the x-axis, as the project grows, we deal with, for example, randomly occurring issues connected to DOM elements re-rendering and network-related issues, right? So as we have more and more tests, these problems occur more and more. On the y-axis, y-axis, as we run tests in parallel, flakiness can come from stuff like bad test isolation or simply the infrastructure that we are testing on. And on the z-axis, we mostly deal with performance issues and flakiness connected to how the tests execute. Um, so let's break it down and let's break down how a flaky test happens on each of these axes and how to fix and prevent that from happening. So let's talk about the first axis and the flakiness issues that arise from the test suites growing in number of tests. I want to give you a couple of examples of what could happen. And a first example would be the DOM flakiness. So consider a following scenario. Here we have an application, and let's say you want to select a card. That's the white element on page, right? So we have two cards in it. And notice how both of these elements contain the word bugs inside, right? So the first one is triage found bugs. The second card is search for critical bugs. Hopefully you can see that, but that's what's written on those white little cards. So based on the code that you see, I'm using Cypress, by the way, but you might have a similar problem with any kind of framework. But let's say we're trying to select an element. Based on this code, which element is going to get selected? That's my question to you. You can feel free to think for a moment which one we would select with this piece of code. So you might be guessing that we're selecting the first one, the one with the text triage found bugs. And the reasoning might be, well, because we are selecting a card element and filter the first one. And you'd be almost right. It's a good answer, but the problem is it's not the most precise one. The correct answer is whichever card will load first. So consider that at the time of execution of these commands, our app would look something like this. We would select card elements, we'd still filter the first one and make our assertion, and that assertion would be passing, but it would also not be testing the element that we want. If we ignore what the app is doing, there's a high chance that our test is not doing what we expect, and therefore it might be leading to flaky results. So this ties to the graphic that I've shown before and I'm showing right now, where these two cogwheels start to grind and not move properly because we didn't really take into consideration the app part of our test automation. So what's the solution, right? Of course, there's no one size fits all, but my recommendation would be to add a level of determinism to your test. So again, like there are many solutions. One of the solution would be to add assertions to your tests that will serve as checkpoints. So places where your app and test are in complete sync. So I've given an example where I'm using the should have length. So I'm first checking how many cards there are, and then I'm moving on. And that should assertion is the checkpoint. And again, like there are many ways of doing that, but the idea of a test checkpoint where your test syncs in with your application is the one that I'm trying to communicate here. So this will pretty much make sure that the test is not moving faster than the app or vice versa. So this example checks number of elements, but it could be an assertion of like loaders no longer existing, API requests responding, elements appearing, and so on. All right, moving on to the next example, where we will discuss network flakiness. So in this example, we have a very simple test with a to-do app. What we want to do is to test adding a new to-do item. So what we will do in this test, we'll visit the application, we check whether we have 0 items on the page, then we add a new to-do item, and then we will check that there is exactly one because we just created one. But as you might have guessed, there's a hidden problem when it comes to playing nicely with our network. Along the test run, there are 2 moments when an API call is made. The first one, the get API to do's, happens when we open the application. Get request fetches all of the to-do items from the database, and it happens when we open the application. Then there's another one. There's a post request that creates a new to-do item. So that's the part where we are hitting the enter key and we're creating a new to-do item. And these tests will be flaky. And this will be because we're not really taking network into account. So let me break it down to you. Let me show you what goes inside the test by looking at this timeline. Imagine this is the test, and at the very beginning, we're doing the visit command, right? So we visit the application, and then in our test, we have an assertion that checks that there are no items in our list. So what happens when we open the application, as I mentioned, the APIs get loaded from the to-do items are getting loaded from the API. But the problem occurs that we're not really waiting for the response. If the response takes a little longer and our assertion happens way too early, like before the response comes back, then we might get into trouble because our API might actually return some items. We can obviously cannot only have one single item in our list at the very end of the test. If the response returns anything, then 0. So an answer to this type of flakiness is obviously not ignoring the network layer. And one of the solutions, as you can see here, is intercepting the set API request and waiting for it. And in this case, we can take it one level further. Not sure if you've seen that, but I have added another argument to my intercept, and that's responsible for mocking. So since we want to test creating of the very first to-do item, we can mock an empty state like we do here with an empty array. So this would result in having 0 items in the list when we load it. This is one way of eliminating network flakiness. There's obviously more, but the bottom line is that when it comes to network layer, it should not be ignored, especially if we want to avoid flakiness. All right, so let's now talk about the second axis of scaling and the flakiness issues that arise from the way test is being executed. And that's test execution, right? So you probably know that your test should be isolated, right? And none of your tests should have side effects on other tests. And Cypress does a very good job of isolating tests. But of course, talking about Playwright, that also does test isolation very well. The example is from Cypress. So yeah. So in Cypress, every its blocks has its own cookies, local storage, and even in between those tests, an empty page is opened briefly. So so it avoids doing any side effects. So in my experience as a consultant, I still see people trying to create tests that depend on each other, and that's not good. That's flaky by design, because you're creating a situation where a test fails or is not even ran because of some outside factor. And what I would normally recommend is splitting these tests, like we have here, into different specs. So we have creating, editing, deleting. These should be different specs. But you might be right to point out that splitting these tests into their own specs files might also create problems once you decide to run your test in parallel. Problem can arise when tests on different machines start affecting each other. So let's say you have a testing account, right? We use one testing account for all of these tests, and you run your tests with it. And while you are running your tests one by one, nothing serious would happen. But as your test suite grows, you realize you should probably run your test in parallel. And that's where trouble happens, right? You may have a test that creates a resource on one machine, a test that edits a resource on second machine, and then a test that deletes a resource on third machine. And depending on how these tests run, you might encounter some flakiness. So either you can delete an item before you edit it, or you can delete a non-existing item, or you can create an item way too late. And in any case, I mean, good luck debugging that. If you're running your test in parallel and they start affecting each other, like it's really hard to debug something like that. So my number one advice would be that even if you don't run your test in parallel today, you should start designing your tests in a way that they're isolated from one another. Because if you your test suite grows to like hundreds of tests, and you then realize you should be making them parallel, it's going to be a lot of work. And in order to do that, you need to think about like what's the common denominator for your test, and make sure that it is separated on separate machines. So to give you an example, if you're testing like an e-commerce site, you should make sure that the parallel process doesn't share the same customer account. So for every machine you will have a different customer setup. And that way they will not be affecting each other. All right. So another common problem is the infrastructure issues. So it's not uncommon to that running your test automation happens on like a staging server, and the performance of that server is way too low. The funny thing is that even without parallelism, your test automation can become sort of a load test. So in one of the companies I've worked with, we were using a testing account that would have thousands of resources on it. And all these API endpoints that were triggered would contain way too much data, and they would strain the database because the select was like huge. Uh, so simply opening an application and make front end fetch those resources was something that made backend work extra hard. And since our tests were nice and granular, which essentially it's a good thing, we would end up opening the application pretty often. But we were pretty much DDoSing our staging server by opening that huge testing account tens or even hundreds of times a minute. So that was a lot of fun. So one of like the quick fix solutions that I have used in the past, in another company, as many tests were starting to fail, the solution was to increase the default command timeout when a test fails, right? So the first time we would have the default command timeout. If a test retried, then we would increase that. If it retried again, we would increase that a little bit more. And this was based on the assumption that maybe the API responses got slower and the whole application needed more time for the elements to render and so on. Now, I want to say that I wouldn't call this a ideal solution. So we can maybe just call it pragmatic solution, right? That would be there before we like are able to fix the infrastructure issues. Either way, the problem at hand, the huge testing account, needed to be solved, and it should be solved ideally by cleaning up the data. So when designing a test suite, there's often a debate on whether you should clean up your test data before the test or after the test. And I generally lean into cleaning up before the test runs, if you really want to avoid flakiness. But if you really want to be thorough, I'm pretty sure that the cleanup should happen outside of the test. So examples could be like setting up a cron job that will clean up a data that was created by the test and run it every couple of hours or maybe every day. Or you can seed your database, and if you're using Docker, that should be pretty straightforward for setting it up. Or you can make sure that you have monitoring set up for your testing environment, uh, so you can keep it healthy and keep an eye on it whether it is performing. There are many ways to do that. All right, so The final axis I want to talk about is about the individual test performance. And as you scale up, the flakiness can become more prominent with each individual test. Um, so let's talk about dry principle for a second. Don't repeat yourself. And that's one popular way of optimization. And I have to say, I'm not really a big fan of the dry principle. My friend David actually might have said it the best: dry does not belong into test. And listen, I could probably do a whole talk and a half on why I think you should probably use less abstractions than you already use in your test code. But I'll just say that overusing abstractions in your test code leads to harder debugging and maintenance. Test code should describe the app behavior, and I've seen way too many instances of code being optimized for abstraction over being optimized to be maintainable. But having said that, I still think there's a grain of truth in the dry principle. If you want to avoid writing flaky tests, you should not be repeating yourself, but mostly in the test execution. So what do I mean by that? Um, let's talk about page object model. So I've even recently on LinkedIn I got some heat about criticizing page object model, but I've been saying that page object model is not an ideal pattern, mostly because it encourages people to overdo it with abstractions and overuse UI to repeat the same set of actions over and over. For example, and again, this is not a page object, this is a custom command from Cypress, but you get the idea, right? So let's say your application is using a login, and there's a good chance that your tests require you to log in. So usually the login object is the first page object you create. And here in my example, as I said, I'm using a custom command, but the idea is pretty much the same. On the right side, you can see that the abstraction being used. I have three tests, and I'm using the login in each one of them. And as we use it, we repeatedly go through UI and perform the login. And while the code is written with the dry principle in mind, and we have like a nice abstraction, the execution itself is repetitive and it's slow, and it's going to show up with our as our test suite grows, right? So there's a danger of flakiness here, and especially if your application has protection against login attacks such as CAPTCHA, right? You might run into CAPTCHA like in the third test here. So the way you can solve this, which I still see not being that popular, is by caching the browser state. Many testing tools already have this. Again, I'm using Cypress because I'm familiar with that, but you have the same thing in Playwright, right? Um, so in Cypress, what you can do a snapshot of the browser after you have successfully logged in. So here I'm wrapping my login flow inside a session function, and when I do that, what happens? I I save all of the local storage and cookies and all of the browser state. And as you can see on the test in the right, I only go through the UI the first time. And the test number 2 and test number 3 will actually just load the cached information. And that happens instantly, right? Um, so you're logged in instantly. And this is the best way to work with login in your test. And it will reduce execution time and it will reduce flakiness. So I highly, highly recommend checking this out, whether you're using Cypress or Playwright. I think this is the way to go. Finally, we're getting to the test idling. And this refers to anytime a test is waiting, right? So you probably know that you should avoid hard waiting as much as possible. But as we know, there are many instances where it seems like waiting is inevitable. So in any case, avoiding explicit waiting should be used whenever possible, and instead timeouts should be used. So the difference between those two is like you can think of timeouts as the upper limits for a test failure, compared to explicit wait, which just waits for a set amount of seconds. Uh, That being said, you should avoid setting the limits too high because you can make your whole test execution very slow, especially if you're going to have multiple tests that have failed. So here in these examples, I'm showing the default timeout is 60 seconds. But if you have 100 tests and 20 of them fail, you just added 20 minutes to your test execution. So that's no good. You probably want that feedback way earlier. Instead, you should make the timeouting granular for a single test. So, for example, if you have a part of the application that's particularly slow, let's say it's legacy. I see some some shouting 60 seconds. That's crazy. I have dealt with applications like that. Uh, but uh, but yeah, if you have some part of the application that's very slow, maybe you can add a longer timer for that. And of course, 60 seconds is exaggerated. So yeah. Um, okay. So one of the most common areas that actually causes the test to be idle is the first page load, right? So usually once the page is loaded, most applications operate relatively smoothly. At least that has been my experience. But beginnings can be messy. So as you visit the application, it can take some time, and it can result in more test flakiness. So the easiest way to make sure that the page is loaded is by checking the DOM. And as the element of interest appears, or maybe the element of interest disappears, like a loader animation, then you're good to go. You can continue on with the test. A slightly more thorough way is to wait for the network calls, right? So as our application opens, maybe it calls some resources from the server, and as the example on the right shows, you can use intercept to make sure that a certain API call has happened, and then proceed with your test. Um, and there are multiple ways of how you can take it even further. So, as this updated example shows, you can wait for a whole array of API calls. So maybe you have two APIs, right? Of course, you may not want to name all your API calls one by one, especially if you have many of them. So you can choose an approach that is slightly more loose and wait for all the requests. There is just one small caveat with this particular approach, with this code example that I'm showing on the right, and that is the should command in the example will usually need to be set up for a longer timeout. This is a Cypress specific thing where you have like different timeouts for like getting elements and making assertions on those versus waiting for an API call. Here we're sort of combining those two, so you need to think about that. So just to put it out there. Um, all right. So let's sum it up. Going back to the three axes of test automation, I think it is valuable to look at the type of flakiness that you're dealing with, whether it is sourced by rising number of tests on the x-axis, the way of how they are executed, the y-axis, or simply by the performance of the automation script, the z-axis. Flakiness is something that should be always watched for. Um, Lastly, don't forget about the fact that you're trying to integrate two systems together, and that the test automation is in essence a challenge of making sure that your test and your application play well together. So, my name is Filip Hric. Thank you so much for having me. You can follow me on Twitter or on LinkedIn. I have put my links in the bio, so if you click on my name, you should probably be able to contact me, and I'll be happy to answer all of your questions. I also shared my presentation in the resources, so if you're interested in any of the code examples or whatever, it's all in the PDF file. So feel free to download that. And again, I'll be happy to chat and answer all the questions. Thank you so much.
That was really insightful, Philip. Thank you so much for that detailed step by step walkthrough of handling or rather unflaking
I'm
the
flaking,
test,
yeah.
right? So we have a lot of questions here, and you feel free to scroll through some of them as well if you want to pick something interesting. But since there's so much talk about AI, do you think we can use AI to reduce test flakiness? I'll just put this one on stage here.
That's something I was trying to look into. And I think there might be ways because AI is starting to get really better and better at taking a complex problem and finding that simple solution. So if you have like a large data set of information, it can like feed off that data and give you the answer you need. I think there is a way of like recording your test, recording your DOM, your network, uh, and your commands, and maybe find some discrepancies. So you put a passing test and a failing test next to each other. You compare them and see, oh, you know what? This test is flaky because there was a network call that took 200 milliseconds longer than in the passing test. So I think there might be something there, and I'm starting to play with that. I don't have a product, but maybe I will. We'll see where that lands.
Great. I will hop on to the next one. Let me see. Yeah. In your view, what are key design principles that separate effective test designs from those prone to flakiness?
um, that's a really good question, and I should probably think about that for a moment before I before I answer that, because I don't have a bullet list for you. But what I'm thinking, and this is maybe just like coming from debates on social media from today, but what I think is maybe a sign of a bad design principle is that is when you are trying to uh, like overdo UI test automation. So I don't know, like I think it's pretty popular the pattern or maybe a form of writing tests, arrange, act, assert, right?
Mhm.
So I have seen many times that the arrange part is being done with UI, and I don't think that's a very effective design. Avoiding UI as much as possible would probably be one of the key principles. Being able, like set the state of your application, see the data, and like do every kind of preparation for the test before the test actually runs. I think that's a good principle to have. uh, Another one that I really like is actually have two more. One, trying to mimic the behavior of your users, right? So if you have a payment flow, you should automate the payment flow. If users are creating to dos, you should have that automated in a way that they do that ideally. And the third principle is make sure that your test code is is readable, right? We're all probably working in teams. Like no one writes test automation only by themselves. Well, maybe there are some people that write test automation by themselves, but maybe they will leave the company and someone will take over. Testing and test automation is a team sport, and it's like very important to be a good team player and be able to create some, like some common language, some common way of doing stuff, so that the code that you write is readable for all of the parties included. So readability is very high on my list of test automation principles. Maybe that's not the most like about flakiness, but I think it's very important.
Makes sense. And speaking of, being into team sport, we also have another question from Denise, which talks about, what are some of the most, what strategies would you recommend to teams who are trying to move from test flakiness to rather app flakiness?
Okay. To move from focusing on test, yeah, uh that's again something that I would need to think on. Like 1 month later, 1 month before, I would be like talking about replay all the time because it did a really good job of uncovering also that app level flakiness. What I think it's important, um, when it comes to app flakiness, is to try to be as collaborative as possible. So for years I've been saying testing is not separate from development, it's not a part of development, it is development. It's in that same box with development. And I think like we need to design our teams in this way as well, right? So if we are dealing with flakiness that is caused by app, this is something that should be taken with a developer and discussed together as a team. And like sometimes I have to like advocate for both sides, right? Sometimes the developer like needs to dive into code and figure out what the hell is going on and why is this application flaky. And sometimes we as testers, we need to stop being such perfectionists, and you know what? Just add that 3-second wait if it's the only way for right now, and we can deal with that later or maybe never. But it's not the end of the world if you add a hard wait to your test, because and I like to give this example, like let's say you don't know why the test is flaky, but if you add 3 seconds of waiting, it's going to be stable, and you're not going to deal with that test for another 2 years. Maybe the time that is spent extra on the CI is going to be cheaper than you trying to debug that test for 2 weeks. Maybe, I don't know, but it's something worth considering. Um, so yeah, I've gone off rails with the answer to that question, but I felt like that's a good example to give on on this one.
Yes, and speaking of flakiness, I would like to definitely boast about one of the Lambda test platform here, which is Test Intelligence, which gives you end-to-end, detailed insights about your flaky test runs, group them for you, just by all you need to do is execute your automation test over the Lambda test suite. If it is basically an app level flakiness you wish to test, you can use the real device cloud for that. And just by executing your test, you will get insights, and you can see over time how your flaky data is increasing or decreasing over time, and you can see that trend happening, which can actually save up a lot of time. As Philip also iterated over here, down the road it ends up saving time. Nobody wants flaky tests coming their way, and we see a lot of questions because of as a matter of fact, because of that here. So Philip, do you find something interesting in the Q&A that you want to pick up as well?
Yeah, I think we should probably answer the question with top votes, because it seems like most people want to have answer for that.
Let's take
Uh,
that one. Yeah.
which is the most common signs that your suite is in serious need of improvement or refactoring. And I love this. In a way, we kind of already touched upon that, but I think probably like most down to earth answer to this one would be when it doesn't give you the confidence you need, right? If so, like if we go back and just take a step back and look at why we even do test automation, right? It's not because it's our job. Well, it is our job, obviously, but it's not because because we need to like hit the keyboard, right? It's because we want to be able to build confidence for our company, for our developers, to ship the newest version of our product, so we can make our customers happy, right? Uh, so we are either succeeding in that part, we are either like doing a great job and we're releasing features like crazy, or oh, we need to wait 1 week before we release this. Oh, we need another 2 weeks. We need another month for testing. I know, like it may be justified, but also like in the grand scheme of things, um, testing might be the part that slows down, right? So if the test automation does not give you confidence, if you have random failures, you're not sure if you can release, then that's a pretty big failure, and there's really some questions that need to be asked. Maybe a refactoring or maybe some serious improvement is in place.
Makes sense. And we do have one space for one more question here. I would like to quickly push that in. When your test suite is in a bad state, how do you prioritize which tests to fix first? What criteria should be used to make these decisions?
Yeah, I think the same principles as when creating test automation apply here as well. So when you start writing your first test, right? The first one that you automate is the most critical one, right? The one like your first test is the thing that makes sure that the application that you're testing even works, right? And then you start with the most risky ones and continue with the less risky ones, etc. So if your test suite is in a bad state, like take a look at the business, right? Which is the most used feature? Which is the most used part of the application that you need to make sure that works? Do your test for that feature works? If no is the answer, then those tests should come first. Like think about the client, think about the priority, think about the people that you're building the application for, right? So those should come first. And then like edge cases and lesser used features and stuff like that, those can come later. I think that would be my go-to strategy.
Perfect. And we also have a follow-up question on that, which says, let's say you have identified the test you're bound to fix. Then how do you
Yeah.
ensure long-term health? How do you prevent them
Yeah.
from becoming unflaked in the future?
Yeah, I think you probably answered that question a little bit with your pitch, right?
Yeah,
Having that long-term overview of your tests and like seeing how the trend goes and looking at it every week and looking at the past month and see like, oh, this like we actually have been rising the number of flaky tests steadily for past month. So maybe we should take a look at the ones that are most flaky, most prone to failing, and make sure that we can stabilize them. These are the tests that fail most often, right? We need to fix them. This is a subset of critical features, and two of those tests in that critical subset are failing constantly, right? Those are like great signals to read. And if you have that long time overview and sort of that bird's eye view on your test, that's going to help tremendously. That has been my strategy in most companies I have worked on, and honestly, I don't really have a better answer for that. Like having that long time overview is going to help a lot.
perfect. Thank you so much for the detailed for taking your detailed insights on the Q&A as well and answering every question in such great depth. And that just about wraps it up. And we already have another sessions running in parallel. So thank you so much, Philip, for taking time out of your schedule. And thank you everyone for joining us from all parts of the globe. Take care.
Thank
Have a
you.
great day. Happy testing, everyone.
Thank you for having me. Bye bye.